Hello and welcome. Let's take a look at the problems that you'll be working on. We are graphing systems of linear inequalities. For the first problem, you ought to check if the point 3, 0 will be a solution to the given system. You notice that the point, when plotted on the plane, will be within the shaded region that is common to both inequalities. Therefore, the point is a solution. On number 2, the point 2, 2 is placed onto the coordinate plane, and then you notice that it ends up being exactly on the line. So right here, the point is exactly on the line, and the line is a solid line. Therefore, we say yes, the point is a solution. Now, what happens when the point ends up being on a dashed line, like it's the case here? Okay, for number 3, you have negative 2, 2. And when the point is placed into the coordinate system, you notice that it's on a dashed line. Point is not included. Okay, so always be careful with solid versus dashed. Okay. On the second section, you are supposed to match the system. Okay, we're going to match the system and see what happens. Let's investigate. We have two inequalities given each time for number 4, 5, and 6. Each of those systems includes one inequality that only deals with x. There's no y. What happens? When you have just x, what kind of line will you end up having? Let's think about it. That means the x value on the x-axis, for all points on that line, the x value will remain the same. Oh yeah, so that must be a vertical line. Okay, a vertical line. Let's see if it helps us to determine if the line will be a dashed or a solid one. For every one of them, number 4, we have a greater than. That's a dashed line. Number 5, x is less than negative 1. It's another dashed line. And number 6, x is greater than negative 1. Another dashed line. So that means even though that, we have now discovered that all of the lines for number 4, 5, and 6, the ones that show x greater than or less than, they are vertical lines. We've discovered that. And they're all dashed. We've discovered that. Even though we did that, it doesn't help us exclude any possible answer choices. So we needed an additional strategy. Let's go to the top equations and inequalities to decide what we can do there. So for number 4, we have 1/2 x plus y is greater than or equal to 3. We are going to isolate y so that you have it in slope-intercept form. That would give you y is greater than or equal to negative 1/2 x plus 3. Okay, so negative, that's pretty much all you need to know to determine if your line is going to be a falling or rising line. I am going to have a falling line. So for number 4, it's not going to be A or C. Okay, so for number 4, now you know it has to be B. That's how you make that decision for number 4. Okay, and then you just look for the other two. Number 5 shows y is minus, here, y minus 1/2 x is less than or equal to 3. Move that into slope-intercept form. Both of them are rising lines. And both of them have a y-intercept of 3, notice. Okay, so the y-intercept will be at 3. So now you have to decide which way to shade. And once you've decided on that, you'll notice that 5 goes with A and 6 goes with C. Now graph the system of inequalities. For this section, you are going to decide what's going on. Take a look. On number 7, you will have only vertical lines. Remember, vertical lines have an undefined slope. They don't ask for it here, but you always want to make that connection. On number 8, both of your lines will be horizontal. Horizontal means they have a slope of 0. Again, they don't ask for it, but you have to make that connection. And then number 9. Number 9 is quite interesting. I want to talk to you about that. Okay, so let's take a few notes on number 9 to further explain what's going on. Look at number 9. When you start graphing this can be confusing. Okay, the pink one can be confusing. You're like, okay, how do I do x is less than or equal to y? Make it look like it's something more familiar. Okay, y, and you can even pretend to have an equation at first, right? Y equals x. Oh yeah, that's the parent function. That's the parent function. I know how to do that. Okay, I start at the origin, and then I go one up, one to the side, one up, one to the right, one up, one to the right, and I get my line. We call it the parent function. Then you go back and you say, wait, but it was an inequality. So then you decide which way to shade. Pick a point. Let's say, mm, let's say 0, comma 5. Okay, that would be on the y-axis. And you plug in your 0 and 5 accordingly and see what makes sense. It doesn't matter whether you plug it into the one that was given or into the one that was rewritten. As long as you say, oh yeah, okay, 0 is less than or equal to 5. That's true. Or in reverse thinking, 5 is greater than or equal to 0. Yes, that's true. So therefore, I would shade right there where the point is actually present. Now, you don't want to forget that you have two inequalities and you want to shade only the feasible region. Just make sure you understand the overlap. Like for number 7, the feasible region would be between the lines. Okay. And the same is true for number 8. Okay. That's what they both have in common. That's what you're looking for. So your solution sets will actually be exactly in those overlaps. All right, good job. Let's do number 10, 11, 12. In this section, you are looking to graph your inequalities. Okay, what's going on? Um, Using two colors is actually pretty handy because then you can see it better. Make sure you understand your solid lines versus dashed lines. Always go back to check. Okay, now when your points are on a dashed line, they won't be solutions. So try to avoid picking points in case they ask you for an example. Don't pick the ones that are on the line when dashed lines are involved. So again, your key is to write it in slope-intercept form. Okay, so the first one, you could rewrite it if you wanted to. And then, yeah, be careful with the inequality itself when you start fidgeting with that. Okay, so what is going to happen if I want to write it as y is blah, blah, blah. So the inequality goes with my variable, of course, and I have to make sure it says the same thing as what the original did, okay? So when I rewrite it, it would be y is less than or equal to x minus 2, okay? Now, of course, it's the same thing as saying x minus 2 is greater than or equal to y. So that's something that you have to kind of get used to and be able to navigate around. So once you have it, you just do your line. On the second one, which is the purple one, and I'm going to just focus on number 10 because the others work the same way. You do the same thing. Y is less than, now 2x moves over, minus 2x plus 4. Okay, so this is how you can rewrite it. Your y-intercept is at 4 for the purple, and you have a falling line. Slope is negative 2 over 1. So you always go with the y-intercept and the slope, and then you start shading. Again, how do I know what to shade? Well, sometimes it's like the shortcut is if it's less than it's below the line. Just pick a point. See what makes sense. Pick 0, 0 whenever you can, or something simple to make it easy on yourself. Avoid negatives as much as you can just to avoid making mistakes. Okay, on number 11, y is greater than or equal to 2. Automatically, you already know it's a horizontal line through 2. And that should be clear at this point. Number 12, a little bit tricky because you had to rewrite it. If you want your y to be positive, okay, so you would say y. Now, division by a negative number or multiplication by a negative number reverses your inequality symbol. Okay, so now what happens? So let's say you're not ready to see what's happening. Don't divide right away. Just rewrite it like this to say, okay, this is the same as the original that I had before. Now, in my next step, I'm going to go ahead and divide by -1. And now I will remember to flip my inequality symbol. And now I know it is a falling solid line, just like my parent function, but now -x. So that was the tricky part. On the final section, write a system of inequalities for the shaded region. On that, I would like to talk to you about parallel versus perpendicular right quick. Even though that's not necessarily the emphasis here, it always is something to keep in mind. So on number 13, you clearly see a line with a zero slope here and a line with a zero slope there. Those are horizontal lines, okay? And horizontal lines will have a zero slope. Keep that in mind, and they will only consist of a y variable, no x. That should help. Those are parallel lines, same slope, okay? 14. Now, I have a horizontal line, which must be the one that deals with y, and I have a vertical line, okay? Oh, be sure you read your label situation here. My axes are right there, x and y. So the lines we're talking about are these. Okay, so now I have a vertical line. I do remember vertical lines have an undefined slope. Okay, that's the one. The pink one is my vertical line. And I noticed that all horizontal and vertical lines, when they meet, they'll meet at a right angle, which means they will be perpendicular. Okay, they will be perpendicular. And technically, with all lines that are perpendicular, you want to keep in mind that you're looking at an opposite reciprocal slope. This situation is weird because you have an undefined slope for one of them. Okay, so that's something to think about critically. Let's look at number 15. I have a solid. Here is the indicator, and I have another solid. Okay, solid lines. And the thick one is the y-axis itself. This, people, is the equation of the y-axis. Technically, x equals 0. But now I'm shading to the left, less than or equal to 0. Pick a point, -3. Is -3 less than or equal to 0? Yes, it is. So that makes sense. And the very last section right here, pay attention to the last one. That's the one that has 3 inequalities. How would you know that you need 3, right? That's a little confusing. You see how this triangle right here was not shaded at all? That's what gave it away. Okay, so you have a restricted situation here. And that restriction allows you to decide that you do need a vertical line, you need a horizontal line. Okay, so that's your vertical, this is your horizontal. No, the other way around. Okay, so the y is greater than or equal to 0 is your x-axis. So that's your horizontal. And then the purple is your vertical. And then, of course, you have the rising line. Ding, 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 ding. And how do you know? Again, the y-intercept, you read that first off of the graph. 2 is the y-intercept, and the slope is 1/1. Okay, so once you have identified that, 2 was my y-intercept, and then I go up by 1 and 1 to the side. And that's how I knew it's actually 1x. Okay, good. I hope that helped. You're doing a great job. Make sure you submit your notes. Reach out with any questions.